Hello and welcome to Continuous Improvement, the podcast where we explore the latest trends and best practices in technology and software development. I'm your host, Victor, and in today's episode, we're going to dive into the world of Kubernetes and discuss an important aspect of cluster management and security, role-based access control, or RBAC. Kubernetes has quickly become the go-to solution for container orchestration and management in modern cloud-native environments. As organizations adopt Kubernetes, it becomes crucial to ensure proper security and access control. That's where RBAC comes into play. So, what exactly is RBAC? Well, RBAC in Kubernetes allows administrators to define granular permissions and control access to resources based on roles and bindings. It follows the principle of least privilege, ensuring that users, service accounts, and groups only have the necessary permissions to perform their intended actions. One of the fundamental components in RBAC is the cluster role. Unlike roles, which are namespaced and limited to specific namespaces, cluster roles apply globally across the entire cluster. A cluster role is a set of rules defining permissions for performing operations on cluster-scoped resources. These resources can include pods, deployments, services, and more. Kubernetes provides a set of predefined cluster roles, such as cluster admin, view, and edit, but you can also create custom cluster roles tailored to your specific requirements. To associate cluster roles with users, service accounts, or groups, we use cluster role bindings. Cluster role bindings grant permissions defined by the cluster role to specific subjects across the cluster. This allows you to control who has access to what resources and define fine-grained access policies for various teams, projects, or applications. Cluster role bindings can be created in the same namespace as the subject or in a different namespace, providing flexibility in managing access control. Let me give you a practical example to illustrate RBAC's importance in Kubernetes. Consider a scenario where you have a team of developers who require read-only access to the cluster for monitoring purposes. You can create a cluster role named read-only with appropriate permissions such as get, list, and watch on pods, services, and namespaces. Then, you can associate this cluster role with the developer's group or their service accounts using a cluster role binding. By doing so, the developers will have restricted access, ensuring they cannot make any modifications to resources. To create a cluster role, you can define a YAML manifest, similar to the following. YAML API version, RBAC.authorization.k8s.io/v1. Kind, cluster, role. Metadata. Name, read-only. Rules. Resources, pods, services, namespaces, verbs, get, list, watch. And to create a cluster role binding, you can define a YAML manifest like this. YAML API version, RBAC.authorization.k8s.io/v1. Kind, cluster, role binding. Metadata. Name, read-only binding. Subjects. Name, developers. Role, ref. Kind, cluster, role. Name, read-only. API group, RBAC.authorization.k8s.io. Once you have these manifests ready, you can apply them using the command kubectl apply ffilename.yaml, and the cluster role and cluster role binding will be created in the cluster. In conclusion, role-based access control, RBAC, is an essential feature of Kubernetes that enables administrators to control access to cluster resources effectively. By incorporating the use of cluster roles and cluster role bindings, organizations can achieve fine-grained permissions and ensure the principle of least privilege. However, it's important to remember that security is a continuous process. Regularly review and update your access policies to align with your evolving environment and ensure that your Kubernetes deployments remain well protected. That's all for today's episode of Continuous Improvement. Thank you for tuning in, and I hope you found this discussion on RBAC in Kubernetes insightful. Remember to subscribe to our podcast for more episodes on technology and software development best practices. Until next time, keep striving for continuous improvement.